días, bienvenidos todas y todos al tercer día de la tercera Semana Internacional de la Cultura Laica, que en esta ocasión se trata de un seminario respecto de los temas de laicidad, ciencia, derechos y democracia. Como parte de las actividades de esta jornada tenemos con nosotros al doctor David Kopsel, quien es PhD en filosofía por la Universidad del Estado de Nueva York, State University of New York, y en Buffalo. Ha sido profesor adjunto de la Universidad de Buffalo y en la actualidad es profesor visitante de investigaciones éticas en la unidad de posgrado de la UNAM y además recientemente se acaba de incorporar a la Universidad Autónoma Metropolitana Campus Xochimilco, además de ser director de investigaciones e iniciativas estratégicas en la Comisión Nacional de Bioética en México. Y es así como en esta ocasión no seguiremos la dinámica tradicional de la presentación de un libro, que se trata precisamente de tener a otro presentador en conjunto con el autor, sino que el autor nos tiene ya preparado un material abundante sobre su libro. Entonces será él quien dará la presentación del libro que ha escrito en coautoría con el doctor Manuel Ruiz de Chávez, quien es el presidente de la Comisión Nacional de Bioética en México. Este libro, antes de dar la palabra a nuestro querido amigo y colega, el doctor David Kopsel, quiero decir que es muy importante y paradigmático para nuestro entorno, nuestro contexto, puesto que a la fecha tenemos pocos libros que precisamente traten los temas de ética en la investigación científica y también no solamente en la investigación en ciencias biológicas o ciencias de la vida, sino también en las ciencias sociales. Creo que ha hecho un gran trabajo para recopilar todas las normas, las guías, las prácticas, lo que se debe y no se debe de hacer en el ámbito de la ciencia para generar conocimiento. Y de esta manera aplaudo este trabajo, sobre todo de alguien que ha venido trabajando con mexicanos y que tiene un interés genuino por el desarrollo de la ética, de la investigación y de la reflexión bioética en nuestro país. Entonces, les pido que le demos una calurosa bienvenida con un aplauso al doctor David Kopsel. Y sin más preámbulo, te doy el uso de la palabra, aclarando que David entiende el español perfectamente, entonces estará presentando tanto en inglés como en español y ustedes podrán interactuar en el idioma que ustedes deseen con David.
Sí, gracias. Y lo siento porque mi español todavía no es muy bueno. Necesito usar inglés, pero el libro está en español. Thank you very much. This is a theme that I've taught about for about 10 years now, beginning when I was in Buffalo. And I'm only going to have a little bit of time to touch on some of the topics. But I wanted to explain a little bit about the approach of this book and why I take this approach when I teach about research ethics and scientific integrity. I've been teaching mostly non-philosophers issues of ethics for the past 10 years. So at Buffalo, most of my students were pharmacy majors, master's and PhD students in medicine and pharmacy. In Holland, where I spent 6 years, I had mostly engineering students at the Delft University of Technology, where I put together this presentation. Now, if you're a philosopher, as I am, and you're trying to teach people ethics or good behavior for practical purposes as opposed to theoretical discussion about ethics, I've learned over the years that it doesn't help if you try to argue about ethical theory. So I take an approach that is a little different. I do want to always explain to them a little bit about the history of ethical theory, because philosophers have done a pretty good job for the past few thousand years of trying to figure out what makes something good or bad and what the value might be behind a particular ethical school. And so I do discuss the three major ethical approaches of virtue ethics, deontology, and consequentialism, and then I move on, because that isn't going to convince people how to behave well if they're not philosophers. So I also do point out that all of those three theories have worked their way into modern applied ethical principles and codes. So the picture in the background here, I'm sure you recognize this from the Nuremberg trials. Our modern notions of applied ethics, of course, are very much connected with the principles that emerged out of the Nuremberg trials and the great body of bioethical research and applied ethics that came out of those trials as well. But I want to introduce that when I'm teaching non-philosophers ethics. I want to introduce that as some background, but then give them a good reason to behave well, even if they have doubts about the principles of modern ethical theories. And I think there are good reasons to have doubts about those, by the way, which we might talk about if you have some questions. And instead I focus on what I think is a little less controversial for scientists and engineers and other, again, non-philosophers, and that is the principles that Robert Merton identified as part of what he calls the ethos of science. So the whole book, that it's a very quick read, it shouldn't take you long to get through, is centered around how to incorporate the ethos of science into modes of behavior that avoid some of the problems that occur with research ethics or scientific integrity. Okay? So I'm going to just give you a couple of quick examples after I talk about Robert Merton's principles. Everybody here should be familiar with Merton's principles, more or less. But he was basically a sociologist of science. He was interested in what makes science work, how it is the institutions of science function as they do. And he identified 4 major values that make science work. And those are universalism, and I'll go through them one by one. Universalism essentially is that the objects of science, the things we're interested in science, are universal. So the laws of nature are not particular to a particular culture or location. They have to be universal for science to work. So when we talk about, say, the law of gravitation, right, it isn't culturally dependent. It is the same everywhere. And the point of science is to uncover these universal laws. And if you don't abide by this principle, you end up with what we might call pathological science. And this occurs historically, where people think that based on local conditions, the laws of nature are different. And that's just not science, according to Merton. The second important principle he discusses is communalism. And in his initial writings, he calls this communism. I think it's probably less loaded to call it communalism. It's essentially the notion that for science to work, it is a communal activity, right? We can't do science if we are isolated from the community of other scientists. So the sort of mythic notion of the mad scientist alone in his attic or basement, depending on the book, building his inventions or researching the universe, is not really doing what Merton considers to be science. You need, in order to do science, to be engaged in a community of other researchers also doing science, looking at the same universal truths, discussing with each other your findings, listening to criticism, and testing. The third principle he notices is disinterestedness. And this is one that is, in English, it's difficult to explain sometimes, because when I'm speaking with scientists about this, they want to know how it is they shouldn't be interested in what they're doing. And that's not the sort of interest that we're talking about, because, of course, you should be very interested in what you're doing. It is your profession, you know, you should have some passion for it, in fact. The disinterestedness that Merton is talking about means that you are not vested. In Espanol, what would be a good word for vested? Committed, perhaps.
No comprometido, no, que tengas, no comprometido, no vested.
Vested.
Como involucrado. Involucrado en el propio interés de la investigación.
Okay.
Involucrado.
Sí. Involucrado. So you shouldn't have you shouldn't have a commitment to a particular result. Okay, you have to be detached from a particular result. You should be very passionate about your search for the truth, but you can't expect a certain result. In fact, what's the most likely result of any experiment? Failure, right? So the process of science is one of repeated attempts and failures, and eventually you might come up with something that substantiates a hypothesis, but probably not. You need to be disinterested emotionally from a particular result, and again, we'll see some instances where people had did some very bad things in science because of that lack of disinterestedness. And finally, organized skepticism is the fourth value that Merton notices. You have to constantly be challenging even your most treasured beliefs. So what is the most successful theory in physics right now, would you say? Can we agree that the theory of relativity is a very successful theory? So far, it hasn't been disproven. It's been about 100 years now that people have been looking for ways to disprove it. It seems to be almost correct, okay? And that's the most we can hope for in science. So, but that doesn't mean we have an unwavering belief in relativity, right? Because tomorrow, what could happen? Somebody could do an experiment that overturns the theory of relativity, that shows some fundamental, you know, if we observe the speed of light as being somehow variable or able to be broken by something, then we would have to question relativity, because the whole foundation of modern relativity theory, per Einstein, is that the speed of light is a constant. Okay? So we have to be prepared to overturn even our most cherished beliefs, even those most firmly established theories in science. Okay? And everybody in the community should be prepared to do that. Good. So those are the four Mertonian principles. Now there's two other important things to keep in mind before we start to figure out how it is to behave well as scientists. One is that science is a socially constructed institution, which is very unusual because it is created ad hoc. There's no central governing body in science. It is a very successful, dispersed, global community of people who are all acting in certain ways, creating an institution by their actions, but having no central form of governance. Okay, not like lawyers, right? We have bar associations and we have the bar, at least in the U.S. If you don't have the bar, okay. In the U.S. we have the bar, and you can get kicked out of the bar if it's not where you go drink, it's the bar of lawyers. So you can get kicked out of that if you behave poorly enough. There's governance there for that institution, but not for science. So how do we organize science and scientists? Oh, okay. And those
it's for
are
you,
different.
but later.
Okay. I thought those might be more books. So how do we organize our behaviors in ways that make science work and that are what we would consider to be ethical? And I broke this down into 5 major areas that are roughly considered research misconduct, authorship, conflicts of interest, intellectual property and data, and duties to society. So those are 5 areas, and for the purposes of the book, I added 2 more chapters to discuss also issues of using humans as subjects, which I'll skip over today. So those are the major 5 areas that I will discuss, and I'm only going to have time to discuss a few of them. The first one is the broadest and sort of least well-defined area, research misconduct. The basic principle behind this is that researchers should be forthright about the bases for their own work, where it depends, as most research does, and as Newton acknowledged, on the work of others. So this ties in with one of the Mertonian principles already, that of communalism. And this is also, it seems, as I've noticed, as I've seen instances of misconduct in academia, this is the one that gets broken most frequently. So you cannot misrepresent data. You can't fail to properly acknowledge your sources or methods. Anytime you do something that undermines the confidence that an objective peer would have in the research or findings of another, you're doing something that is harmful, in fact, to science. Again, tying this into the method of the book and my pedagogy in this area, I'm not going to try to convince you that lying is somehow bad, because that's a big, long philosophical discussion. But I assume that as a researcher, as somebody involved in the academic and scientific process, you're interested in at least making sure that science works. So if you fail to do these things, what are the implications for science? Okay, not for your soul. This is so tying in with the secular aspect of this conference. What are the implications of science? And who's this fellow? This is I love to use this example because people don't expect ancient scientists to have been frauds or engaged in scientific misconduct. But this fellow, there's a clue up there. This is Ptolemy. How do you say in
Ptolomeo.
Ptolomeo, okay. And what did he do? Anybody recall? Astronomy mostly, right? He did a number of other things. He had a very bad but a decent, good guess, I suppose, for the time, picture of how the solar system operated. The Ptolemaic view of the solar system was Earth-centric, okay? So he did his best to try to figure out the mathematics that would make that work, right? But he also did something very important that lasted for thousands of years, even beyond the Copernican revolution. That was he created star maps, okay? He created and published the best star maps that ever existed for at least 500 or 600 years, and that were used long after his death. But he did something wrong. He did something which we could call scientific misconduct. So to get back to this principle, it's ethically, not only is it ethically wrong when you claim someone else's work as your own, but it can cause a problem for other scientists. And as it turns out, for others who are non-scientists as well. You have to leave a clear research trail. Without that trail, other scientists may waste their effort, and in the case of Ptolemy, people might actually get hurt. Ptolemy, what did he do? Well, it seems that he used data that he couldn't have possibly observed in his maps. Now, how could we figure this out, sort of forensically? How might you figure this out? Well, it's fortunate for us that Ptolemy never left a very small area within his life. He was within about 60 kilometers of the same place for all of his working life when he claimed to have accumulated the data that went into his star maps. Now, based on that knowledge, how might we determine that Ptolemy might have plagiarized the work of somebody else? Sí, sí, porque por otros entes más sur, los estrellas es extraño, ¿sí? Es diferente. So he put in stars that he couldn't have possibly seen, that were probably observed by a fellow who lived about 200 or 300 years before him, who had also accumulated star maps that probably Ptolemy had access to, that he incorporated into his own. We don't know the extent to which his maps reflected his own observations and incorporated the observations of others. And all it would have taken is a simple thing I tell my students to do, and that is a reference. Okay? All he needed to do was add a reference. But he didn't. Now, what's the big deal about not adding a reference to these star maps? Es plagio, sí, pero ¿por qué es peligroso para ciencia?
Porque se falta la confianza necesaria que debe tener en que se basa la ciencia, en que confías en que lo que está ahí es lo que dice que sea.
Sí, sí, esta es verdad. Pero tienes otros peligrosos. Sí. Aquí.
Alma.
Because you don't leave a trail of the accumulation of knowledge.
Mhm.
You don't have clear antecedents of what happened before.
Okay.
So
and
that's really problematic to know what were the steps that led you to that hypothesis or that integration of knowledge.
Perfecto, sí, absolutely. And in the case of Ptolemy, because he was using data that was 200 years old, older than his own observations, it causes a real problem for observers after Ptolemy. Okay, because his star maps will have discrepancies. Those stars move over time. Okay, the stars in our sky are not fixed. Although Ptolemy thought they were, which is part of his error.
Can I ask you?
Sí.
When was these Ptolemy maps made? At what time was this?
It would have been about, I don't know, about 70 AD, I think. It would have been about 2,000 years ago. But we know that he was copying maps from Hipparchus, who was 200 years before
Okay,
him.
but my question is, creo que estamos extrapolando exigencias, requisitos
Sí.
muy elevados del día de hoy, cuando hace 2000 años seguramente el recorrido del conocimiento, poder llegar a tener acceso a lo que otras personas estaban haciendo era muy difícil, era muy complicado.
Sí.
El conocimiento estaba en los conventos, en los monasterios, ¿no? Por eso no sé el ejemplo de Ptolomeo bien cómo se aplica ahora, porque las redes y las formas de comunicación del conocimiento científico es muy distinto.
See, the area where this helps is for forensic astronomers, okay, because now they can publish about this issue, actually.
Claro.
The problem is that in the Middle Ages, when people were depending on star maps for very important things, there was no such science. So they couldn't tell which stars. If you went south, right, and you're in your boat and you went south and you started seeing stars that were in Ptolemy's maps that weren't where they ought to be, this could actually be dangerous, right, if you're navigating by the stars. But moreover, and for the purposes of this discussion, it cheats other scientists after Ptolemy who have depended upon his work as being accurate, and who might publish based upon it or do their own work based upon it, from having a clear reference to the real observations. Okay, so this harmed science, and it may have harmed people. I don't know if anybody ever crashed a boat because of inaccuracies in the maps, but it's possible because people did navigate by the stars, and his maps were used. So, how does this happen? Well, again, in my experience, there's all sorts of reasons why people cheat and don't provide references. One of it is time. We're all in academia very pressed by time and the necessity to publish. And again, in my experience, people start with very small errors like this and then become more confident to make bigger errors as they go. And there's a number of other social pressures involved in academia that seem to be involved. My take-home message for this is that if you care about science and research, there are very good reasons why you need to always reference your data. You need to provide anybody else with a clear path backwards so they can see where you get your your observations or your data when you publish. Okay? I use this this handout when I teach the course. It's 10 Academic Frauds Who Had Everyone Fooled, it's called. And right here at the top, and I was teaching in Holland, as I said, for 6 years, is a Dutch psychologist, Diedrich Schtoppel. Has anyone heard of him? No? Okay. It was a big scandal. That's why they started being concerned about research ethics in Holland about when I moved there. Because of this case, Diedrich Schtoppel, it turns out, made up a lot of his data, published 60 papers or so that had to be retracted. And how did he get away with this? Well, he never, if anybody asked to see his data, he never let them have it. So he claimed to have done these studies, psychological studies, and then kept the data to himself. There's a fair amount of doubt that he did the studies that he published about. He may have just made up a great deal of it. At some point, one of his graduate students, fearing for their future, sort of blew the whistle on him. This happens entirely too often, but the reason I use Ptolemy is because it's not new. Okay? Researchers have been failing to provide accurate sources for entirely too long, and it messes up science. So the sort of long and short of it is good research conduct. So you have to be open about one's sources and attribute correctly, leaving a clear trail, being honest, cooperative, and careful, because being good is actually good for science. Okay? It undermines science. It wastes everyone else's time if you're not. Okay. Let me quickly move on. I'll probably only be able to get to 2 of my topics. The next one I wanted to talk about is authorship. I put these 2 out front because these are the areas where we see most instances of misconduct in modern research and academia. Authorship is highly contentious. It's also very interesting because it's culturally specific. And I don't mean that just as in, the norms of authorship in Mexico are different than in the US or Europe. I mean, in each field, the norms of authorship differ. So the norms of authorship in chemistry are different than they are in philosophy, etc. And that's problematic. So I tried to figure out how to teach this subject in a way that isn't culturally specific, and to identify some principles that can help you figure out issues of authorship on your own in a way that accords with the values of science. So what counts as an author? In my view, entirely too often, people are named as authors on papers where they didn't do anything deserving the title author. Okay? This is a real problem, and I'm going to try to give you a secular, a scientific basis for how to determine who is an author. Now here's an example. This is a pretty modest example. There are now papers out there that have more than 1,000 authors. Okay? This is a modest one because there's only 20 authors, I think. And it's about astronomy. It's about the clustering of massive galaxies. Now, why are there all these authors? We can get a clue for that here. All right? Why are there so many authors on a scientific article about galaxy clusters? And I think there's probably reason to doubt that all of these people deserve to be authors on this paper, but why do you think? Any ideas? Yeah.
Because you need different sides of observation.
Very good, right.
Not everyone can see the same stars from the same place.
Very good. Okay, well, or parallax might allow you to better determine location in the sky. Exactly, right. So having different observation locations is very helpful. Yeah, so the reason I use astronomy examples in this is because I did a chapter for a book on ethics in astronomy, of all things. So, but it turns out there's a lot of interesting issues in ethics of astronomy, and one is this problem of having to gather data from different locations on Earth, and sometimes in space. Now, there are, as I say, these cultural phenomenon that result in people getting named authors. And some of them are particular to the science you're in. But here are some broad areas that of agreement among those fields. So it could be that somebody is named as an author because they got the money. All right, if you get a grant, right, that underwrites a study, it's very common for the person who got the grant, the PI on the grant, the principal investigator, to be named as an author. Or, as I found in Europe is often the case, it could be that there's the chair of a department or somewhere in a hierarchy in a laboratory, or in some other position of authority that makes them culturally likely to be named as an author. Again, this differs from field to field. Philosophers, we don't really have that problem. Okay, we all go off and write our own papers on our own. Nobody collaborates and nobody co-authors. It's a very modern phenomenon to co-author in philosophy. But in other fields, especially in many scientific fields, it's very common to name the person who runs the lab or the chairman, etc., as an author. But I'm going to suggest that there is a measure that makes sense scientifically, that we really should abide by. And I'm going to give you a couple good sort of compelling reasons, I think, why that should be the case. You should ask whether the named person, the named author, actually contributed to the writing of the paper either through developing the ideas, doing critical research and analysis, or actually stringing the words together in the paper. I think one of these three things, or maybe all of them, all right, but at least one of them has to be present for the person to be named as an author. And I'll provide you a good reason why by way of a negative example. So things that don't count are copy editing. And my wife is a scientist. She writes articles in genomics, which I don't know much about. But because she writes in English and she's Mexican, I often do copy editing for her. Now, my H index would be really high if I included those as acts of co-authorship, right? It's a 7 now because in philosophy we don't get high H indexes. I could have like a 13 or 14 by now, which she has, by being a co-author with her on papers in, scientific journals. It doesn't count, okay? Copy editing doesn't count. Discussing the paper around the water cooler, right, or over coffee or a cigarette doesn't count. You should ask whether the paper, as conceived and written, would be possible with or without that person in order to be an author. Okay? So some hand in both the conception and realization of a paper warrants a claim of authorship. Okay? All authors ought to be involved in the drafting process. So I believe anybody who's named as a co-author should be involved in drafting, somehow either reviewing drafts and adding comments or criticisms, at least reading it, okay? Believe me, and this doesn't always happen, okay? So let me give you another example. This fellow at the top, can't see him very well. That's a fellow by the name of Hwang Woo-suk. Some of you know who this fellow is. This is the Korean stem cell case. Well, because I want to point out co-authorship. And this is a real... So I'm not going to talk about poor Hwang Woo-suk, who went to jail, by the way. But I am going to talk about his co-authors. So this is the list of co-authors for the paper that was retracted from a small journal called Science. And the co-authors in this paper, some of them claim they had not read the paper, and yet they were named as co-authors. So, to reiterate my point, at least read the paper that you are being named as a co-author on. Ask some questions about it. Provide some criticism and comments. Okay, because later, when that paper is retracted, are you going to be exonerated for not having read the paper on which you were named as a co-author? No, in fact, I think it makes you more guilty. Okay, so the counterexample I have is that you will be harmed if you take credit for a paper that turns out to be wrong. Okay, again, I'm not calling on any high-minded ethical theory. This is a really practical thing in science. Yes?
It's not on.
Sí. Okay. I have a question. What would you think of a person, and that happens a lot with the direction of theses or projects, that gives you like the best idea he
Yeah.
or she has, no? Suppose, I don't know, I've been thinking about this new theory about astronomy or whatever,
Good.
and then another person develops the theory, but it's not the intellectual one that came up with the idea, just the person that really did the research. What would you say? Like the first person that had the idea actually and communicated to the other one has a right maybe to sue the person
No.
that did the development, or what will happen with
No,
these
no.
ideas that some brilliant people communicate and just not develop for themselves?
Yeah, I think if my whole, I write a journal article in Science, right? And the reason I wrote it is because I had a conversation with you that inspired this idea to write it. I think I have a positive duty to ask you to co-author with me. Okay. Obviously, there's no right to sue because ideas are not property. So, but I think I have a positive duty to ask you to co-author with me if you're the reason I wrote this paper. So going back to this slide here, I ask whether without the person to be named, would the paper as conceived and written be possible? Now after that, yeah, you should read it, right? And we should do other things that are indicative of co-authorship. But yeah, I think you need to reach out to the person who inspired you to see if they want to co-author with you. If they don't want to co-author with you, the least I can do is acknowledge them, okay? So yeah, I put acknowledgments in papers, talking to so-and-so helped me a lot. Yeah?
But this assumes that there is an original idea.
Yeah, not necessarily.
What?
It might
From
just
my
be
point of-
inspiration.
Okay, just inspiration.
Right.
Okay.
Sometimes, and then it turns out sometimes some of my most brilliant ideas were not mine to begin with because it came out of somebody else's, a conversation with someone else. And sometimes people will remind me of those conversations, and I do feel I have a positive duty to incorporate them somehow into that.
Okay.
But yeah, there's no theft or anything like that. But I think, yeah, we should try to help each other. This is the communal aspect, right, of science. And otherwise, what are you going to have? You're going to have a bunch of people not talking to each other,
Yeah.
right? Because they're afraid somebody's going to steal their ideas. Well, that's pathological in science. That doesn't help science. Okay, so here's the quick and dirty way to figure out who should be named as an author. Who is willing to take the responsibility? These people who took the benefit of a publication on their CV that was in Science. By the way, their H index hasn't gone down since it was retracted, which is unfair. But who gets the benefit should be the same as who gets blamed if something's wrong. Okay? So taking the benefit means taking responsibility also in case something is wrong in that paper. So you must be willing to accept the blame. And I think this is an important inquiry to undergo when you are doing a paper jointly or a book jointly with someone else. Ask yourself, to what degree, and ask the other person, to what degree are you willing to take responsibility if something's wrong in this? And if they're serious about it, then they ought to at least read the paper or book. And as we know, that doesn't always happen. So I only have 5 minutes to get through a topic that usually takes half an hour, and I'm not going to try to do it. What I'd rather do is ask if you have questions. I encourage you. I brought 20 copies of this book, but this is a freely available book. It was published through a grant from CONACYT, and it's also available as an ebook online. You can download it anytime you want. I have my copy on my reader because I give away all my physical copies all the time. But I want to ask if you have any questions, any criticisms or comments. Again, lo siento para mi inglés, pero es mejor. Trust me.
No, también tu español es bueno. Does anyone have any question for David?
En español
En español pueden hacerlo.
David, I would like to insist on the point I tried to make,
Yeah.
which I wasn't able to do it either in English nor in Spanish.
Okay.
But about Ptolemy
Yeah.
as an example, because I understand what you want to say about that derived from the Ptolemy case, but at that moment when Ptolemy did what he did, probably he wasn't doing what you are saying he did, in the sense, at that time there were no rules about how to copy or mention another research on the area and how to add it to another one.
Yeah,
I don't know how were like the circuits, how the knowledge travel through different places when people used to live in the same place all their life without moving around. And I don't know how Galileo, if ever, got hands on Copernicus writing, and if Galileo quoted Copernicus for having said, like the
I do, and I don't mean to pick on Ptolemy, but actually the notion of referencing the work of others has been around for thousands of years. Okay, you can read Aristotle and see his references to other philosophers. You can see in Ptolemy that he does reference some other works. Okay? What he doesn't reference is Hipparchus, which is probably where he got this data from the southern hemisphere, and that's strange. It may have been an oversight. Maybe we lost it along the way.
So the standard of reference already existed at that moment.
Researchers in what few fields there were referencing where they found things. Libraries were full of books that other people were using to write their own books. So, I mean, it could be that something went wrong along the way that is entirely innocent. Okay? I don't mean, again, I'm not anti-Ptolemy. But I think that in this case...
But I was more interested in the history of all what you are saying.
Referencing
because
other works.
Because technology seems to play a great deal in all what you are saying. So at the time when technology wasn't like the one we have now...
Right. Referencing others' works where you get something that you are quoting has been done for thousands of years. Okay, in our culture, in the Western culture, in Eastern cultures, no. Okay, and there wasn't the same standard of reference, and that actually persists today as an issue when you're teaching research ethics. Okay, so this is. So when I have Eastern students in my classes, it's a culturally relative notion, this notion of reference. So I try to tie it to the norms of science, which I think are universal. Thank you.
¿Alguien más? Alma?
I don't know what were you going to say in this conflict of interests, but I think this idea that science should be neutral or impartial is kind of also biased.
Okay.
What would you say that how can scientists, and by scientists I mean also like social scientists and all of people that do also humanities research, how can we best deal with our own ideologies? Because I think that I see more problematic, and I would say that will be a more conflict of interest between not being transparent about your own ideology and how this ideology is related to the work you are seeing, to the things you are observing. So I would like to know what's your personal take on this.
Yeah, well, my discussion of conflicts of interest mostly has to do with money. So where we see problems of academic misconduct arising from conflicts of interest, my examples tend to focus on where you have a funder who wants a specific goal, or you want a specific goal because of issues of profit. It could be your motivation is ideological, okay? So to get to your point, I think that too can be a problem for science. So and here's why. Maybe your ideology is impelling you to come to a particular conclusion or to ignore other arguments or sources that have differing conclusions. And it could be that in a field in the humanities there's more room for that sort of expression of your ideological interests. The problem with that is that if you get pegged as being somebody who's only writing from a particular ideological viewpoint, people are not likely to pay as much attention to you, which happens. Okay, so that's the danger, I think, for you as a researcher. It's better if you don't get viewed as somebody who is trying to push a particular ideology, but who is appealing to more objective matters. Now, that doesn't mean that we can't have goals that are policy-oriented. So I also, I've written books that have specific policy goals. But again, I back it up not from a particular ideological viewpoint, but with as much objective material as I can. Otherwise, I'm just going to be seen as a propagandist. And that's not good for anybody, I think. But regarding conflicts of interest, if I'll just quickly state it, if you have an interest in something like profit, this can undermine your audience's confidence in your methods and conclusions. And examples, I use a really stark example where somebody died. The Jesse Gelsinger case. This is the case I use. I urge you to read it in the book. It's really fascinating and horrible. And it arose because of, I think most people agree, because there was insufficient attention paid to alleviating potential conflict of interest, because actually there was a lot of money on the line. So that's what I'm mostly concerned about in the book. But yeah, I think you need to also be concerned about your ideology too, because it might undermine people's confidence in your conclusions as well. But that doesn't mean don't try to do something good. Okay? Any other questions? These are great questions. So again, if you take one of these, please sign. There's a sign-up thing. It's a government organization. They need me to track every copy. So, transparency.
That's good.
Thank you.
Muchísimas gracias a David Goxel. Para concluir, solamente quisiera hacer breve comentario porque ya tenemos que pasar a la siguiente mesa, y ya que David trajo a la mesa de discusión a Hwang Hu, el coreano, que le ha hecho mucho daño al área de la ciencia de las células troncales, por los conflictos precisamente éticos, no solamente en la falsedad de los datos que mostraba su investigación, sino que en la manera en cómo disculpen, aquí tengo que traer un problema relacionado con violencia hacia la mujer y hacia la mujer que está en el laboratorio también. Extrajo los gametos de su estudiante de postdoctorado para llevar a cabo una investigación, y lo que también se evidenció, o sea, es muy profundo la discusión ética de este investigador coreano, que era el director de ciencia y tecnología de Corea aparte, y que estaba recibiendo mucho dinero para hacer ciencia de células troncales, es que no sabemos si se obtuvo un consentimiento real o si se estaba explotando también a las mujeres que trabajaban en su laboratorio para una intervención que sabemos que pues es invasiva. Entonces, este es otro de los problemas relacionados con las mujeres en la ciencia, y creo que también, perdón que lo tengo que traer, y no me gusta mucho el ejemplo porque es en el área donde tengo una pasión profunda, ¿no? Pero también debo de despojarme de esta pasión e ideología para revelar los problemas. Otro gran escándalo, y que está relacionado con esta última parte que nos habló David respecto de responsabilidad ligada a transparencia. La transparencia en la investigación es muy importante también, y la responsabilidad que asumen algunos directores o jefes de laboratorio respecto de la autoría de un paper ha llevado también a estos investigadores a la muerte, es decir, al suicidio, por no poder llevar por no poder tener en su vida presente una falta ética grave como la de no leer un artículo donde él es el autor principal, pero, y en este caso otra vez con células troncales, el descubrimiento de las famosas células STAP, que son similares que se decían ser similares a las células troncales, pero resultaba ser que la estudiante de postdoctorado también de este científico del Instituto Riken de Japón había dado datos falsos y fue reportado en la revista Nature Science, lo que lo llevó al suicidio. Pero bueno, esta es de la responsabilidad de la que nos hablaba también David cuando aceptas la autoría en un paper en donde no has hecho nada y ni siquiera has leído el paper, de uno de los científicos más prominentes en el área de células troncales. Entonces, agradezco muchísimo a David Kopsel por la autoría de esta obra y por la responsabilidad que implica para los autores la autoría de esta obra. Muchísimas gracias, David.
Gracias.